Hello, everyone. Welcome back to Space Tour Live for another episode of Space Roundup. I'm Jamie from the Space Tour team, and tonight I'm welcoming our amazing guests, Nick Howes and Terry Moseley. So, how are you both doing tonight?
Pretty
Very
good,
well.
all things considered.
Yeah.
Yeah.
It's we believe that our usual introductory host is seeing a concert at the O2, which barely survived the winds a couple of weeks back. So yes, it's an interesting time, shall we say? Anyway,
Yeah. How about you, Terry?
Yeah, all well. We survived the storms here pretty well. A few bins shifted around and a few pots blown over, but nothing worse than that.
Good
all
stuff.
good.
So, yeah, it's great to see you both. So,
Yeah.
thanks to everyone who's joining us tonight on YouTube or Facebook. And yeah, big hello to everyone watching us on Catch Up. We're really appreciating the support from our entire audience, and everything that all of you do is helping us here at Space Store. And we're trying to keep growing our online space community to make sure that we can keep providing you with all the latest and greatest space news from across the universe. So I'm sure you're all going to enjoy tonight's episode with Nick and Terry. Let's take it away.
Cool. It's been an eventful few days, hasn't it, Terry?
Absolutely.
Everything
is eventful now. Yeah.
We're going to be covering not so much the politics, but some of the ramifications of what's been obviously happening and dominating all of the news from a space perspective. But we thought we're not going to start with the elephant in the room. We're going to start with something a bit of a happy story. And our favourite space telescope seems to be really, really pulling everything out of the bag, doesn't it, Terry?
Yeah, absolutely. I mean, this just sort of is getting more and more unbelievable. The launch and deployment and commissioning and so on of the James Webb Space Telescope is by far the most complex operation that has ever been attempted in space, particularly as it's all done remotely. Started off basically once it sort of got out of Earth's orbit, things started to happen. But now everything is happening at a distance of almost 1 million miles. And as I say, it's incredibly complex. Every single stage that has happened up to this point has been mission critical. And yet everything has gone, as the Americans would say, nominal, which means basically it's worked perfectly. And it's almost too good to be true. And I hope that's not putting a hex on it. So we have followed the progression of the deployment and the alignment and so on every program since it launched. The latest one is that all 18 of the mirror segments, which you're probably familiar with, the hexagonal gold-coated mirror segments, are now functioning as one giant mirror. So the 18 separate images that we showed you last time when they were testing have all now been combined into one. And the result of that is that image is now so bright that they've had to switch to a slightly fainter star. Otherwise, the image would be so bright that it would be impossible to get a fine detail in it. So the first star was magnitude 7 roughly, and the latest one that they're using now is magnitude 8.8, just about what the limit of what you can see in a good pair of binoculars. So this is actually the third of 7 total phases that they go through before the mirror is absolutely totally 100% accurately aligned. It's called segment alignment and image stacking. And by the way, they've also now perfectly aligned the secondary mirror, which of course is an equally critical thing. Now, the point about this is the accuracy that they need to achieve is unbelievable. It's about a 10 millionth of a meter. Every single mirror has to be exactly aligned to that degree of accuracy and to function together as one huge mirror of that size. The next phase, which they're now starting, that's underway, is what's called coarse phasing. And one of the instruments, the NIRCam, NIRCAM, near infrared camera, it will be taking spectra. In other words, splitting up the light from the star from 20 pairs of mirrors, and that in a sequence that will allow very, very accurate vertical positioning of the mirrors. As I say, they not only have to be aligned with each other to that degree of accuracy, they have to be exactly the same distance away from the secondary mirror to an accuracy of a 10 millionth of a meter. And by splitting the light up into the spectra, that enables you to make very, very fine adjustment. So that is ongoing at the moment. I hope this isn't putting a hex on it, but basically everything so far has worked perfectly. And, barring unforeseen incidents or some snag that we can't imagine at the moment, it is going exceedingly well. And it looks as if this telescope is going to soon, well, about July, I think, before everything is finally commissioned and tested, including the instruments on board, not just the optics, we're going to see some absolutely amazing results from this telescope. I'm sure you'd agree, Nick.
Absolutely, and you only have to look at, I mean, in standard astronomical terms, us amateur astronomers up to professional astronomers, we have to do this with telescopes. It's collimation, it's basically mirror alignment, etc. But this is taking things to a whole other level. Things like the point spread function, for example, the kind of the optical competency, as it were, of the system, as you said, has got to be off the scale. I mean, they're looking at image resolution that's never been achieved before. It's a really good question, actually, as well, from somebody I know quite well via Twitter. Chris, who basically has brought up this question about deployment. Is it as complex as the Hubble servicing, or, for example, building the ISS? It's a very, very good question. You think about it, the Hubble deployment and the Hubble servicing missions, that was all, a lot of it was handled out of SSCO and the NASA Goddard spaceflight team. And I know people like Ed Razak who worked there, who worked on the Hubble servicing team tools and trained up a lot of the astronauts in building those tools. That was incredibly complex, but it was only at 450-kilometer orbit away from the Earth. So were things to go wrong, they would have a second shot at it, or they could basically, almost recover from it. And having humans in the loop does make things, as we saw with the Apollo program, a lot easier. You only have to look at the Mars rovers, for example, and how complex it is even to get very small samples, drilled cores, etc., into sample tubes and have them there for future retrieval, whereas on the Apollo missions, having humans on the moon, very easy to pick up the rock. So having humans in the loop in any system tends to make it obviously more challenging in some respects, but a lot easier in others, in that people can make very quick decisions. If you've got the James Webb, which is a completely autonomous system, it had to deploy hundreds of separate components to a level of precision that nobody had ever seen before, and to be tested. And don't forget, it was never integration tested on the Earth. It couldn't be, because it was too large. You could never do a full integration test of both the main mirror, the instrumentation section, and the sun shield in one go, because it was just too big for any TVAC or vacuum chamber anywhere on the planet. So in terms of against the Hubble, I'd say more complex. The interesting thing with the Hubble, the cost of some of the servicing missions, they could have built a new Hubble and launched it. And that's the thing that they can't really do with the James Webb. There was talk this week talking about things like Starship and being able to send out a Starship mission, but then you've got to build an orbiting platform. You've got to be able to get out there, you've got to be able to service it in situ. It would probably cost almost as much in the long term as the initial cost anyway. I mean, the overrun costs on the James Webb are quite spectacular, but really, really, achievement has been kind of they've got there in the end, but despite the overrun costs. Against the ISS, again, it's a very interesting question, because the ISS, you've got something the size of a football pitch, and you've got, again, the largest structure ever put into orbit. And there's all sorts of ramifications now with what's happening in the Ukraine with the ISS, etc. We'll go on to that in a little bit. But in terms of building the ISS, again, you had humans in the loop, and you had the shuttle as a very well known and capable delivery system, along with the Soyuz delivery systems as well, for various stages and various instruments, etc. And you're at a relatively low orbit and relatively short distance from the Earth, so if things were to go wrong, or things were to be misplaced, or a spanner was to be lost, or a bolt was stripped, with the Hubble, for example, there's talk, the Mike Massimino book, if you've ever read it, where he literally had to kick the door off because one of the screws had threaded to access some of the components that they were aiming to repair on the Hubble during one of the last servicing missions. Massimino talks about in detail in his book, and how terrified he was that he was going to get it all wrong. And they had to build the capture plate system, where the screws, obviously, when they remove the screws, obviously you're in a microgravity environment, you don't want screws drifting around everywhere and adding to the already enormous debris problem that we've got. So I'd say, from a technical standpoint, as a single point of failure mission, as it were, with a completely autonomous system, this is probably the most complex that's ever been achieved. You look at some of the deep space missions, New Horizons, the Huygens landing on Titan, etc. They're incredibly complex, but I think this one, probably along with Rosetta and the orbital dynamics on Rosetta, just still blow my mind. But again, you've got humans in the loop there. It's not a completely autonomous system. I think with James Webb, it's a case of it was fire and hope, and it had to work. So yeah, it's a really, really good question, Chris, and I'd say probably up there in terms of the most complex thing ever achieved in space.
I think the difference with the ISS is that there are a whole lot of separate components, and what if one of them failed or didn't attach properly, that wouldn't affect the operation of all the rest. In terms of the JWST, if they don't get the optics right, the whole thing is a failure. So it's mission critical to get the optics perfectly aligned.
Well, that's the thing. And also, you're looking at a radiation environment that is well beyond what the Hubble is experiencing as well. We're looking at deep space radiation environments. So the electronic components, all of this, don't forget, as it's an automated system, is relying on computational systems to do the deployment. So all of that's got to be able to sustain, high levels of what's called TID, kind of disruption events, C events as well, which are all kind of radiation specific events that can really knacker up onboard computers. On top of that, you've got whatever micrometeorites, you've got a whole ton of things that could potentially go wrong. And when you're looking at the level of precision here, and the only time I've ever seen a level of precision equivalent to the James Webb, I think is probably one of the ESA missions where they were looking at gravity wave detection, the LISA Pathfinder and LISA missions, where essentially they had two beryllium spheres, two beryllium cubes in the LISA mission anyway, planned they were going to be about 1 million kilometers apart, and they were going to be able to detect a gravity wave based upon the deflection of a laser between these, and the incident angle of that deflection was the equivalent of apparently your thumbnail at around about the orbit of Neptune. The width of your thumbnail. So it is astonishing what they're doing here. Yeah. We've got to keep on top of this one. As Chris has said in the chat as well, it's not just, we talk about the 7 minutes of terror and that amazing video that NASA put out with the Curiosity landing and Adam Stelter, etc. This is 7 months of terror. This has got to go right at every single stage. And so far, they've nailed it. As you said, they're on point. It's a nominal mission. So, I personally can't wait to see what a proper first light's going to be now that we've got a star, and they've not even focused that star yet. You look at that image, and most ground-based telescopes will think, "Oh, that's a brilliant image." That's not even close to what they're aiming to achieve. So, they're going to be able to resolve details on the surface of Betelgeuse with this thing quite happily. Sunspot details, etc. So bear that in mind. It's off the scale. Anyway, moving on to our next story, which is. A little bit of a difficult one, shall we say, to talk about. This has got a reasonably happy / sad ending. So what happened, obviously, in the last week or so, just under a week now, if you're watching us live, unfortunately, the Russian Federation decided that they were going to not do what they said they weren't going to do, and they were surrounding Ukraine and on military exercises for several months and amassing on the border of Belarus and Ukraine, etc. And they invaded. Now, the international response to this has been universal. The condemnation of this has been rightly universal. And various organizations and agencies, FIFA, the Football Federation, the International Olympic Committee, athletics committees, got everyone, tennis, golf, everyone, arts committees, the Bolshoi Ballet, all sorts. Russia has basically been excluded now from all international operations in any capacity. You can't, have boats docking in British ports anymore. It's getting really, really serious. Now, one of the agencies that were kind of taking their time over this, and you can appreciate why, because the European Space Agency isn't just a single entity, it's 22 member states. And even though the United Kingdom came out of the EU, as it were, with Brexit a few years ago, which is probably the greatest catastrophe in modern British history in terms of science in particular, we are still a key part of the European Space Agency of ESA. The UK Space Agency, I've had many dealings with the UKSA and ESA. I used to work for ESA many years ago, contracting for them. It's a large organization, and it's like the trees in Lord of the Rings. They take their time to discuss things. So last Friday, Joseph Ashbacher, who's the Director General of the European Space Agency, put out a statement that pretty much got everybody riled up, because whilst all of the other major organizations, governments, intergovernment agencies, the United Nations, etc., were condemning Russia and saying that they were going to impose massive sanctions on them. The ESA, the European Space Agency, was saying, well, we're still going to collaborate with Russia and we're going to monitor the situation. And that drove most of social media to go into meltdown in terms of condemnation of his statement. And I know from talking to friends at the UK Space Agency and at the European Space Agency, they were very, very dismayed by this statement. It wasn't, but it was a thing that they weren't allowed to talk about, because the UK Space Agency in particular, the civil servants, they're bound by government rules and regulations. They can't really talk about this stuff. It then kind of escalated, and much like it happened with the FIFA decision, whereas FIFA initially said, oh, Russia can play, but they can't fly under their own flag, etc. The level of public anger at this kind of drove ESA to kind of up their statement. So a couple of days later, they said, well, we're now monitoring the situation. And again, it really didn't cut the mustard, as it were. And, various people, ex-UK Space Agency, etc., were like, well, they're not really reading the room here. This is really, really quite significant. And the biggest problem for ESA was the upcoming launch of the ExoMars mission. So ExoMars was, planned from 2005. This is a multi-decade long planning and preparation, mission to land the first successful European Space Agency lander on the surface of Mars. They've had, previous attempts. Obviously, Beagle 2 got down to the surface of Mars. EDL worked flawlessly, but the deployment of the solar panels failed. The Schiaparelli mission dumped a ton of hydrazine all over the surface of Mars and was a complete catastrophe, although the orbiters have been very good. And this is the thing, that Russia were not only building the launch system with the Proton rockets, and I've always had major objections to that, because Russia have got a 0% success rate of ever getting anything to the surface of Mars. So it's almost like a jinx. It's like the kind of 13. You don't use 13 with any mission now since Apollo 13, etc. So that was a big part of the problem. But the even bigger part of the problem for ExoMars was the Kazakh lander. So the Kazakh lander basically is the landing system and was also some of the surface science. So the Rosalind Franklin rover was going to be basically put down on the surface by the Russian landing system, and it itself at its landing station was going to be doing an inordinate amount of surface science. Now, as I said, it started off in 2005. Around about 2009, NASA got involved in this, and they were going to be collaborating with the European Space Agency. Then they pulled out in 2012 and kind of left NASA and left ESA in the lurch, completely in the lurch. So ESA then approached Roscosmos, and let's not, we can't condemn the entirety of Russia. Here, there are an awful lot of very, very good scientists, engineers, arts people, sports people, etc., who are fundamentally opposed to everything that's going on in Russia here. So let's not condemn everyone in Russia. But the head of Roscosmos, even late last week, was threatening operations on the ISS and saying, well, what are you going to do if we suddenly decide that we're not going to boost the orbits and stuff? It's like these veiled threats were not going down well with the international community. Now, the ISS has got its own set of protections and legal frameworks in place. And the astronauts on board, they're consummate professionals. They're not going to go, hopefully not trashing a $200 billion space station that's doing remarkable science. But the other missions, there was this inherent, you can't be involved with Russia anymore. And again, the public pressure was building and building and building. And now ESA have put out a third statement where they're saying, well, we now don't believe that ExoMars will launch this year. And instead of just saying it's cancelled. So there's still some kind of debate over the level of, constraint that they're putting on this. They're still leaving a little crack in the door, which they shouldn't be. I mean, Russia, Roscosmos head, he should be universally condemned as well. There's some really bad statements coming out. Vladimir Putin is threatening the entire world with nuclear weapons, and you can't take anything he says verbatim or as truth, because he said he wasn't going to invade Ukraine. So I think this condemnation of what's happening, whilst it's terribly sad for the scientists involved in the ExoMars mission, and I've got friends, people who work at Airbus, for example, in the UK, have been working on this for years, and there's a lot of scientists who've put in most of their careers into getting this mission. And it's not just ExoMars, you've then got the sample return. This was a whole kind of series of missions that were designed to, the Fetch rover and the orbiter, etc., designed to bring back the first surface samples from Mars, for laboratory analysis. So there's a whole ton of knock-on implications here. Now, what can ESA do? Well, clearly launching anything with Roscosmos is a big no-no right now, and there's a whole other debate going on with OneWeb at the moment. OneWeb is a big, mega constellation provider, part owned by the British government. It's a massive $400-500 million investment from the British government into them as well. They're planning on launching from Kazakhstan on a Soyuz rocket in the next few days, and again, they're not getting a lot of good publicity over this because they should be pulling out. And it's really interesting to see what they're going to do, because they've got a lot invested in this, and it's a really difficult situation. Talking to a few people and some people in the chat here on Twitter today, it's a really difficult situation for them because they've got this massive investment in OneWeb. Now, we've all got our opinions on OneWeb and Starlink, etc., and we hate the whole debris potential threat and the light pollution issues and the astronomy issues, etc., that are being caused by these constellations. And my hat doff tip to Elon Musk and his I'm going to send Starlinks into Ukraine. That was a good move, in terms of helping the Ukrainian people. But Putin's already proven, and we talk about the ASAT test in a bit, via his ASAT, anti-satellite weapons test, that he's not afraid to take out stuff in orbit either. So there's a whole ton of issues here. So what would ESA do? Well, could they use, a different launch system? Yes, integration into the fairing, the rover integration into the fairing is not a big problem. So putting the rover in a different mission, not so much of an issue, the rover part anyway. In terms of the lander, that's a whole other ball game, because the landing mechanism obviously has been designed around this Russian landing system. Now, obviously, Adam Steltzner and his amazing team out of JPL and etc., and the NASA team, who have successfully landed 2 rovers the size of Mini Coopers on the surface of Mars with the Sky Crane that everybody said wasn't going to work, and it worked flawlessly. That to me would seem like a logical option. But then the re-engineering of all of this and the surface science, etc., that came from the Kazachok lander, that's not trivial. This is not a quick fix. And 2 years sounds like a long time, but believe me, in the space sector, it isn't. It's a really, really rapid amount of time. So developing something in that space of time, not going to happen. What could happen? Well, if what happens, what develops in Ukraine develops hopefully in a positive way for the Ukrainian people and the West, in that hopefully Putin may be deposed. We don't want to talk about the politics too much, but something needs to happen. Then possibly collaboration with Roscosmos could occur again, because they've got some great scientists. They're not bad people, not all of them anyway. I don't know, Terry. What are your thoughts on this? It's a really difficult situation.
Absolutely. And as we're saying a wee bit more about this in the ISS section later, generally speaking, the scientists keep out of the politics, which is the way it should be. But unfortunately, as you've alluded to, the head of Roscosmos is very much political on this. He was threatening, as you say, to let the ISS come down on Russia, on America. In fact, he made a rather silly remark saying the ISS doesn't fly over Russia. Well, it does very much so. Not over Moscow, but over other major cities like Volgograd and Rostov and Kursk and Vladivostok and so on. So the thing is, you cannot target that to come down and hit a particular country. It's difficult enough to do with that one relatively small satellite, let alone something the size of a football field. You could get it down, within a day of when you intend to get it down, probably, but not just where it's going to land. So there's no guarantee that he could get it to hit America, for example. The other thing is, unfortunately, again, he's being very political about it. He's changed his Twitter profile picture to showing him in military uniform, showing that he is very much sort of part of the military establishment there and backing Putin on the outward side anyway. And also the Russians are now pulling their personnel out of Kourou in Guyana.
Yep.
So, it has become political from their angle. And I think ESA has no choice, as you say, but to respond accordingly. The launch isn't due until September. So as you're implying there's no way that they can get this all redesigned to meet that launch. Thing is, then there's a 2-year launch, or just over 2-year launch window later. It's roughly 2 years apart to get decent launch windows to Mars. So that gives us basically nearly 3 years and before you would actually get a chance to launch. And it might just be possible to reorganize things within that 3-year period, but that's outside my area of competence to say, but it's possibly doable. When you think that the Americans got to the moon, in 8 years, basically, from when Kennedy made his statement, it should be possible to redesign something within 3 years to get it onto the surface of Mars.
It should. I think, you're looking, obviously, 2024, obviously, as you said, due to the nature of the orbits of Mars and the Earth in terms of the optimal transfer. There's a comment from Chris, and hello to Ground-Based Space as well. Talking about hopefully your good lady is feeling better. It's fantastic to have people in the chat. But, again, a good comment from Chris in the chat talking about the use of Starship. Now, this is it's a really interesting idea in that if you wanted to get a rover onto the surface of Mars, if you were to just put it into Starship and Starship worked as Elon Musk is claiming, then you don't need a separate landing system. You literally just roll it out, or you get a crane and you basically deploy it onto the surface of Mars from the Starship itself. Who knows? Musk to the rescue is a really interesting idea, and given the tonnage capability of Starship and what it's going to be able to deploy, definitely onto the surface of the moon, probably hopefully onto the surface of Mars in the not too distant future. If they were to miss the 2024 slot, and as you said, I'm working right now on a radiation hardening project. That's been 2 years just to get it to kind of a basic testing phase right now, and things are quite slow when it comes to space because you've got to get all of the preparation done. There's so many systems that you've got to get in place, and testing chambers, etc., have all got to be done. If NASA had the capability to almost deploy a sky crane mechanism and a launch vehicle that was, Rosalind Franklin, is slightly smaller in terms of physical size than the landers that they've already put on the surface of Mars. So it's not inconceivable that there could be some modification there, but they'd have to move really quickly. As I said, the key issue is then the surface science and the complete lack of it. Whether or not that is critical to the mission, the rover's the critical, one of the critical components. Obviously, surface science, a fixed landing site is very nice, but the rover's capability and the drill in particular, and what it was aiming to achieve in terms of looking at the methane issue, etc. I'd hope that they could find another solution. It's not going to be easy at all, and Russia have really done themselves no favors here because, to be fair to Roscosmos, they've got one of the most reliable launch systems for human spaceflight in the world. Designed in the pre-Apollo era, original concepts, etc., and still flying successfully in a modified form to this day. I don't know. I don't know. It's going to get worse before it gets better. Everybody in the world is hoping now that the whole situation in Ukraine does get a lot better, and from the scientific community, they all seem to be rallying around, etc. And there's a lot of scientists have come out and said that they're fundamentalists and opposed to everything that Putin's saying and doing. So hopefully there won't be a kind of Stalinist era gulag, chucking of all the scientists into some Siberian hellhole, which nobody wants to see because they've got some brilliant people over there. And we just, from the bottom of our hearts, we wish everybody well here. Everybody who wants to do really good science, we want to see them achieve and do something good. So let's just see and keep the situation under review. Anyway, next story. Back to Happy Land. This one's quite good.
This is one that fascinates me. You've all heard, I'm sure, of exoplanets, which are planets going around other stars. That's where we started off with the definition of an exoplanet. And we all know our own solar system pretty well, with 8 planets, or 9 if you count Pluto, forming around a star. And that's, as far as we used to think anyway, that's the way solar systems formed. You had what was called a proto-solar disk, which is a condensing cloud of gas and dust, which would gradually spiral in as it contracts under gravity, and eventually when there's enough material in the center, the pressure and the temperature builds up and nuclear reactions start and you get your star, and surrounding that is the remains of what would now be called the protoplanetary disk, the disk of material that never actually got into the star until it started forming, and that would then condense and form planets. And that's pretty much, in simple terms, the way we think our own solar system formed. And of all the the roughly 5,000 exoplanets that have been discovered up to now, that's more or less the same. In fact, we've even seen planets forming in protoplanetary disks going around other stars. And of all the 5,000 or so exoplanets, till I come to the qualification at the end, they've all been going around other stars. And that's basically how we detect them, either by them transiting in front of the star, and we can then see the tiny little dip in light from the star as that happens, or by their gravitational pull on the star as they orbit around it. They will move the star very slightly forwards and backwards relative to us, assuming that the plane of their orbits is directed in our direction. So, as I say, about 5,000 of them were known, but now we have discovered quite a few what are called rogue planets, or free floating planets, FFPs, planets that are not orbiting any known star. How does that happen? Well, if our original theory was right and the planets formed around a star, they must have been kicked out by some sort of a gravitational interaction with one of the giant planets in that particular exoplanet solar system. And that sort of thing can happen. There's an awful lot of very complex orbital dynamics going into this, but we understand that in the formation of the solar system, the giant planets Jupiter and Saturn have actually moved in towards the inner part of the solar system and then back out again. And during that process, they may well have ejected some previous planets in our solar system out into interstellar space. So that's possible. The other thing now that we have seem to have found is that some of them may actually have been formed on their own out in space, not as part of an exoplanetary system. And the reason we think that is that we found a whole cluster of them in Scorpius. And the reason we've been able to detect them is that because they're not quite stars, these are quite big objects, they're not quite big enough to be a brown dwarf, which is the smallest and faintest sort of object that we can even classify as a star, because it's shining by a very primitive, simple form of nuclear reaction. They're not quite big enough to do that, but they still have some of the original heat that they had from the kinetic energy as the material fell in to form the ball of matter that became the planet. So they're just sub-brown dwarf in size. And if you get them when they're relatively young, they still have that certain amount of background heat, and that means that you can detect them in the infrared. And using that technique, they have discovered between 70 and 170, I think it is, or so exoplanets in the cluster, as you can see in that image there. Just in one very small area of the sky. And if we discovered that many, some of them are still to be confirmed, but that's the theory at the moment, between 70 and about double that number, then there must be a whole lot of them right throughout our galaxy, and presumably through other galaxies as well. So that revolutionizes our ideas basically on how planets can form. Now, there's another way of detecting them, and that is if they happen to pass in front of a faint background star, we get what's called gravitational lensing. In this case, it's called microlensing because the objects are very small. And basically, the gravitational field of this rogue wandering planet briefly focuses the light from a distant star. It's something that we're quite familiar with in the distant universe with galaxies and black holes and quasars and things like that, micro or gravitationally lensing objects behind them. The trouble about that technique is it only happens once. It's not repeatable. So what you see is a star suddenly become bright and then faint again, and it won't happen again, not in anybody's lifetime. And we think that in one or two cases, we've actually detected that one of these invisible dark planets, because they're not reflecting any light. Obviously, they're not near any stars, so they're not reflecting any light. If it passes in front of a background star, you get this momentary, brief illumination of the distant star, and then the planet passes on past it, and it's not repeatable. So it's very difficult to say that definitely was a microlensing event by a rogue planet. But by using the infrared capabilities that we have now, then by detecting the infrared from these planets shortly after they're formed, it does seem to be a way of detecting a large number of these free-floating planets. And that really does revolutionize our ideas of how other planets may form. So I'm sure you have thoughts on that too, Nick.
Oh yeah, and there's a good question about. I mean, we'll come on to this load of good questions. We'll come on to the ASAT one in a minute. But will the James Webb be able to see these? Yes, and that's the beauty. The James Webb working into the far infrared, and it's not only the planetary microlensing events; it's also the planetary occultation events. So if you've got a background star cluster where you've got potentially not one but multiple either lensing or occultation events as the planet drifts across that field of view, if you can then effectively determine an ephemeris or a very simple kind of trajectory of that planet, then being able to target, observe that region with something like the James Webb, where you can say, okay, well, the planet occulted these stars here. We believe that the planet is moving in this direction, kind of rough direction, as it were. Then being able to swing the James Webb into action and say, right, can we pick up a target object here? Now, we are talking about light years away. So exoplanets, obviously with current exoplanet image detection, what we're looking at is occultation systems where you basically black out the star, as it were, to then look at the planets orbiting it. And you've got to, apart from, we've seen spectroscopic observations where you get spectroscopic redshift variants, which lets us see that planets are there. You've got spectroscopic observations now of planetary atmospheres, and again with the James Webb, that's going to get even better and better. I think that this could be really revolutionary, because if you were to get a large-ish kind of protoplanet, and don't forget these are going to be, you say heat from them, we're talking still incredibly cold, because these things don't have a star. They're not orbiting a star, so there's nothing to keep them warm. They're out in deep space, as it were. So whilst they will and may have latent heat, as Terry was saying before, you're looking at something incredibly cold. So, but being able to get spectroscopic observations on them, especially if you've got Jupiter kind of sized planets or slightly larger, kind of up to that brown dwarf kind of interface boundary. Yes, absolutely. The James Webb should be able to deliver remarkable results with this. It could be that our galaxy and all of the other galaxies are absolutely littered with these things. We just don't know. You look at star systems, what happens with star systems if you've got planets where a star goes supernova, and then you've got planets that are orbiting essentially nothing, as it were. There's very little left, as it were. So, and the shockwave, who knows what happens? Lots of interesting stuff there. But yeah, I love this. You always find these great stories, Taylor. Absolutely love it. Really love it. Moving
The other
on.
thing is some of them may have exo moons of their own.
Oh
So
God,
that's
yeah.
even another angle. Right, sorry for interrupting.
No, not at all. It's brilliant. Right, so another good, brilliant story. This made my Twitter feed go into absolute meltdown. Last time I looked, the statistics on it was over 100,000 kind of impressions and views, and tens of thousands of likes and what have you. It was crazy. This wasn't publicized. Nobody really gets why not. So the Indian Space Agency, ISRO, 2019, they attempted to land on the surface of the moon with the Vikram lander. That crashed. That's been imaged by the Lunar Reconnaissance Orbiter, but they were able to keep an orbiter going around the moon, Chandrayaan-2. So fabulous little orbiter with a very detailed high resolution camera. Now, Lunar Reconnaissance Orbiter, going back to 2009, obviously the technology is not going to be as advanced as something 10 years later. Plus the orbits on LRO tend to be a little bit higher, a little bit more inclined orbits. Chandrayaan-2 seems to be able to go to a slightly lower orbital inclination, lower orbit relative to the moon than the Lunar Reconnaissance Orbiter. And they just snuck these out. They didn't really tell anyone. ISRO just went, oh yeah, here's some images. So if you had access to the Indian Space Agency's data store and database, and you have to create an account and log into it, etc., you could get access to these raw images, and they are absolutely staggering. The level of detail, they are looking at 10 to 18 centimeter per pixel resolution from orbit. What they've done is flyovers of both the Apollo 11 and the Apollo 12 landing sites. Now, they've got others in target and in mind, and I've seen some of their initial data on Apollo 14, for example, which nowhere near the clarity that we're seeing here with these two. If you've not seen the images yet in their absolute entirety and glory, please see them, especially the Apollo 12 ones. So the Apollo 11 ones, I mean, the images are, this is Apollo 12 that you can see in the image there, but the Apollo 11 one, where you've got West Crater, and, you know, all of the, if you've watched the movie First Man, where Neil Armstrong walks to the edge of West Crater, you can see the footsteps. You can also see the fallen over flag. There's a kind of inference of a dust covered fallen over flag in the Apollo 11 image. You can see the camera, you can see the outset, you can make out the individual legs of the lander, you can see the high gain antenna. I mean, the shadows being cast by the cameras, etc., are all over these images. The footprints on the surface of the moon where the astronauts walked, they're all there. Going on to Apollo 12, you've not only got Apollo 12 obviously in the images, but you've got the Surveyor mission, which Apollo 12 landed only a few hundred yards away from, and, you know, Pete Conrad and Alan Bean walked over to, and, you know, they had issues obviously with their color camera and what have you, but with the Apollo 12 ones, you can still see the flag, because with Apollo 11, Buzz has always said, you know, when they took off, the flag got blown over. And yes, the images from Apollo 11, it looks like from the location where they planted the flag near to one of the cameras, you can see something that's kind of partially covered in dust. But these are absolutely remarkable. And what I love about them is that the Bart Siebels of this world. Now, if you don't know who Bart Siebel is, he's the idiot who basically went up to Buzz Aldrin and said, "You've got to swear on the Bible that you landed on the moon because you're a liar and you didn't, and it's all fake." And then Buzz, I think he was aged in his mid-70s at that point, basically punched him and knocked him flat out. I mean, these moon conspiracy theorists are just a joke. They really are. And there's millions of them all over the world. It's really funny seeing the social media reaction to this, where people have said, well, you know, how are you gonna deny this? Oh, it's Photoshop. Well, you can't do that in fact. Why? What would India gain from doing this in Photoshop? There's nothing to be gained here. It's just a ridiculous premise, and the fact that all of the images show so much detail. And we were saying just before we came on air, you know, it really gives you an incredible appreciation of just how complex it was, using 1969 technology, very basic computers, you know, slower than, you know, some of the audience may remember the ZX81, which was my first computer back in 1981, and the ZX80 just before that. I mean, these computers were on the par with that. And they managed to land on the moon 6 times. And then the manual override control that Neil Armstrong did when he landed Apollo 11, and you look at the field near Apollo 11, it's just craters everywhere and rocks everywhere. And Apollo 12, the same. It's just an absolute minefield of how do you land on that. And then, like I said, look at Apollo 14. That just takes it to a whole other level. And then 15, even more complex. And 17, when we start to see the 17 images, you know, it's just going to be off the scale. I just, it beggars belief. I absolutely love this. Bit of a special place in my heart because I was born the day that Bean and Conrad were picking up rocks on the moon in 1969 in November. So I've always had a soft spot for that. I've been able to very luckily hold some of those rocks when they were being analysed by one of the British universities. They'd gone under laser ablation, so it was safe to kind of hold them. But it's stunning. It really is. And having met Alan Bean and Dick Gordon as well at various conferences and sat on panels with them, it's wonderful that legacy, you know, especially for their kids, you know, Sue Bean and Amy, and, you know, the family that's still alive, you know, Alan's, you know, wife and his children, etc., and Neil's sons. It must be amazing for them to see this stuff at that level of detail. I don't know what your thoughts are, Terry, but
Yeah, absolutely. Yeah, I agree with you totally. Just one sort of minor point for anybody that is relatively new to this. It shows the importance of a low sun angle to give you the shadows. If you look at the full moon through even a very powerful telescope, it is quite hard to make out any detail on it because the sun is shining down directly from overhead on the surface. The best time to look at the moon is when the sun is shining at an angle, and then you get the effect of the shadows, and that shows up perfectly there. If you were just looking at the white parts in the sort of the center of that image, relatively hard to make out what it is. Is it just extra white rocks or something or other? But once you see the shadows there, you can see the actual shape of the spacecraft there as thrown by the shadow. And that's why it's basically not photoshopped. That is genuine imagery of a human artifact on the moon. And it's just mind-blowing, as you say.
Yeah, it's the footsteps. I mean, you just think that 50 plus years ago now, people walking around on the surface of the moon. I don't know. It always has. It's been to me, it's always been the greatest technical achievement in human history, and until we land on Mars, I think that will be the case. But yeah, more please, Israel, keep going with Chandrayaan-2, keep delivering these amazing images, and we just hope to see more and more of them. Apollo 15 is going to be a good one as well, because Hadleyville, obviously, it's one of those locations that's quite easy to see even with amateur telescopes from the Earth, and it's one of those things that you love showing kids, in particular when you're out observing the moon, and at the right time of the lunar cycle, and saying, you see that kind of thing that looks a little bit like a river there, well, Apollo 15's just there, kind of thing. It is wonderful to see stuff like that. Anyway, happy story. Moving on again to another happy one.
Yeah, and we're back to planets again, and another exoplanet. It's not that the ones in our own solar system aren't interesting enough. You just have to sort of have any sort of a review of what we found out over Mars and so on over the last decade or two is just mind-blowing, not to mention the outer planets and Pluto, which I'm calling a planet for the purposes of this, the imagery that came back from that, and indeed the comets that we have in our solar system, again, just mind-blowing. But there is a fascination about exoplanets because they are outside our own solar system, and for a long time they were only just sort of hypothesized. But any Star Wars fans will know Tatooine, the planet in Star Wars which orbited not one star but two stars, a binary star. And there's now been confirmation, this is the interesting bit, of a Tatooine-like planetary system, a planet orbiting two stars, and it's nicknamed a Tatooine planet. Binary stars are very common, actually, in our galaxy. Maybe 50% of all the stars in our own galaxy are actually members of binary or triple systems. Our sun is it's not unique, certainly, but it's certainly not the case that most stars are single stars. So whenever you have a planetary system orbiting two stars, what does that actually imply? Well, it would imply very complicated orbits for a start. But to get back to the point of this was originally discovered by the Kepler Space Telescope by the transit method, which I referred to earlier. In other words, whenever a planet passes in front of the star, as we see it from Earth, you get a tiny little dip in the light. And you keep looking at the star and you see that repeat every so often. And you can work out the period of revolution of the planet around the star, how big it is, all sorts of things about it. You can infer from what its atmosphere is like and so on. But there is another method, and that is, what again I referred to this earlier, the radial velocity method, the Doppler shift. A planet has mass, only a tiny fraction of the mass of the star that it's orbiting, but nevertheless the two orbit around a common center of gravity. It's not just that the planet orbits around the center of the star. And certainly with a planet as massive as Jupiter, the effect is quite considerable. So as a planet orbits a star, it will gradually and very, very slowly pull the star slightly towards it whenever it's on the far side of the star that it's orbiting, and slightly towards us whenever it's on the near side of the planet that it's orbiting. There's a very, very gentle orbital shift. And by studying the spectrum of the star with very, very sensitive instruments, we can detect the motion of the star backwards and forwards as the planet orbits around it, sometimes just by a matter of a few centimeters per second, which is again almost incomprehensible. So what happened with this one is that a relatively modest telescope on Earth, a 75-inch diameter telescope, which is small really now by the latest standard of professional telescopes, which go up to 10 and up to 30, 39 meters, and one's being planned at the moment. A 75-inch telescope, sorry for mixing the metric and the imperial, but it's called a 75-inch telescope.
Jacob Rees-Mogg would love you.
Yeah, okay, indeed, yeah. It's at the Observatory of Haute-Provence in southern France. And just using the radial velocity method, it was able to detect the motion of the two stars in this case being orbited by this planet, which is pretty fantastic. And the good thing about that is it shows that you don't now need a very complex and very expensive space telescope like Kepler or like TESS to detect these planetary systems. It can be done even with a relatively modest telescope here on Earth. So they're hoping to be able to work on that and develop on that and look for some more of these, what are called circum-binary planets. Circum going around, and binary, they're going around a binary star. So again, the universe, as they say, is not only stranger than we imagine, it is stranger than we can imagine. And dear knows what we're going to discover next. But if you're a Star Wars fan, Nick, I'm sure you'll appreciate the Tatooine connection.
Massively.
Yeah.
I mean, what got me into space, bizarrely, a lot of people have been asked this many times by various magazines and what have you, but what got me into space was Star Wars. My dad, at the tender age of 7, saying to my mum, "Oh, I want to take him to see this new space film coming out called Star Wars," and that was it. I was just like completely hooked. And the first film I ever saw on my own as a child growing up at about the tender age of 10 or 11 was The Empire Strikes Back, and that still to me is one of the great movies of all time. And having visited Tunisia and been to Tatooine and you know, seen the sets and stuff, yeah, I'm a massive fan. We did some work when I was working at Yamaha Musical Instruments with Skywalker Sound as well, and they'd send us crew jackets and stuff. But that was for the Phantom Menace, and we don't talk about that as Star Wars fans because it's an abomination. But yeah, it's amazing. You just think that there could be somebody walking around on a desert world, like orbiting those, those 2 stars at some point. It is fascinating, and as you said, the universe just keeps throwing up more and more remarkable stuff. Unfortunately, moving on to our next story, a bit closer to home, things get thrown up that they shouldn't be thrown up. Back to our friends in Russia. So last November, after China and India and the United States had previously done and been universally condemned for doing it, the Russians decided to launch their own ASAT, anti-satellite missile weapon test. And last November, they hit one of their defunct satellites, Cosmos 1408, and turned it into basically a big cloud of debris. Now, if you just look at some of the modeling done by Exo Analytics, Norse, Comspoc, etc., what they do is they will model what the impact debris cloud was going to look like. And as the Earth's rotating, this cloud kind of gets dispersed and creates an absolute mess for everybody. The ISS has already had to cancel multiple EVAs. They've had to change their orbit, etc., because the intersection kind of between the International Space Station's orbit and the debris field from 1408 was there. What's now becoming more and more apparent, according to Comspoc, who's one of the big kind of debris observation kind of agencies, as it were, is that these clusters aren't forming like big debris clouds, as it were, that are encircling the Earth. They're forming kind of clumps known as squalls. Now, what the problem with that is that the number of conjunction events, so collision avoidance maneuvers, CAMs as they're known, essentially all around the world, there's almost a common interest, obviously, and common communication between all the satellite manufacturers to say, well, what we've got is what's called TLE data, 2-line element data. So that gives us a rough orbit for what's flying overhead. That's being augmented and updated constantly by the likes of Exo Analytics with their multi-telescope networks and saying, well, that orbit's not quite there, it's moved a little bit. Or you've got the Russians, for example, or other agencies moving their satellites because they want to change the orbit, like Maxar are doing right now over the Ukraine, modifying their orbits so they can get optimal images, etc. The orbits will change. Now, as the orbits change, obviously, this data needs to be updated because then you've got the potential, if you move into an incorrect location, of a collision event. What happened with 1408 is that the trajectory of the ASAT missile and the trajectory of the satellite itself created a very high inclination debris cloud that has now, as I said, formed these what are called squall clumps. That's kind of going at around about 82 degrees, kind of almost kind of circumpolar, as it were, or orbital. What you've got going in the other direction are multiple Earth observation satellites at around about 97 degrees. You've got this 97 degree, 82 degree interface, basically in opposite directions. So what you've then got is a potential orbital velocity is around about 8 kilometers per second, 17,500 miles per hour. If you've got opposing directions, you've then got something close to 15 to 16 kilometer per second impact capability. Now, even something the size of a grain of sand hitting something at 16 kilometers per second, do your maths, do your physics, K equals half mv squared, you're going to total a satellite. You're going to kill an astronaut easily if you're, to hit someone on EVA. And these squalls are getting so bad that Comstock are now estimating anywhere between 30 and 50,000 collision events per week. Now, at the moment, we're looking at thousands per month. This is how bad this situation is. They are literally saying that it could be anywhere. I mean, they're estimating in April around about 40,000 conjunctions in a week in April. Now, somebody said, Ground-Based Space said Kessler. Yeah, the Kessler syndrome, which is, the most famous kind of thing that's doing the space rounds now, the IAU, and everyone's really, really beginning to panic about this. I've been talking about this for years. Other people have been talking about this for years. Carolyn Porco, who I know has listened to this show, the mission manager on one of the Cassini, on the Cassini imaging system, worked on Voyager, is a massive kind of exponent of trying to stop this happening, because between OneWeb and Starlink and China and everyone else, this problem is only growing, and these ASAT tests are getting more and more and more of a problem. And what will happen some point in the future, it's going to happen, is what's called the Kessler syndrome, where you get a collision domino effect of a cascading debris field. Now, given what's currently happening in the Ukraine and the fact that Russia obviously performed an ASAT test, and it's an interesting comment again in the chat thread, was that the kind of start of this? Who knows? Who knows what Putin's kind of master plan was? But if you've got, and we were talking about this just before we came on air, if you've got Elon Musk being very benevolent and saying, right, I'm going to send a ton of Starlink dishes over to the Ukraine to help the Ukrainian people, to attack a Starlink, to do an ASAT strike on a Starlink, would be a declaration of war, in effect. And we would be pretty much in a World War III situation, because it's a United States entity. But if Russia were clever about this, and they are, they're not stupid when it comes to orbital dynamics and space capability anyway. If they were to say, right, well, we've got a few more defunct satellites. Russia have currently got about 300 satellites in orbit. By far the biggest orbital, satellite operator, as it were, right now is Starlink. They're in the thousands now. Out of the 4,850 that are up there, Starlink is about a quarter of the total number, or just over a quarter of the total number. So if they wanted to, they could take out in strategic orbits and move what they needed in terms of their spy and observation satellite assets into orbits that wouldn't be affected by this. They could strike something in a strategic orbit, destroying it, and put that into direct contact with Starlinks, if they so want, and there's obviously thousands of Starlinks floating around in different orbits, etc. But if they wanted to do a demonstrator of what they wanted to do, they could do it. And that's the big worry, obviously, with these ASAT tests. The ASAT test should never have happened. India, I had a running battle with the Indian Space Agency and with the Indian government and with the Indian military, which was quite terrifying, on LinkedIn over this a couple of years back, where I was basically telling them how stupid they were and demonstrating the orbital, problem. And they were saying, oh, no, it's going to deorbit. Some of that Indian stuff isn't coming down for 200 years. So, and that's the same with the Russian ASAT test. Some of the, orbital inclinations on some of this stuff, it's not coming down anytime soon. And it's constantly a battle with the ISS. What we've also heard in the last 24 hours is that the Russians are now saying it's very unlikely, because their contractual obligations on the ISS end in 2024, very unlikely that they're going to move forward unless the whole situation changes, and that's unlikely unless Putin's deposed. So their reliance on the ISS and their need for the ISS, and now the fact that they're talking with China and they're saying that they want to do collaborative work with China, who knows where this one's going. But these ASAT squalls, these clusters of debris, are a major issue, and we can only be grateful that the James Webb is at a far Lagrange point and isn't really going to be impacted by this. But I don't know, Terry, your thoughts?
Yeah, absolutely. I mean, they're estimating on one day there's going to be 14,000 in a near miss situation with these other low Earth observation satellites. The other thing, of course, is it's relatively easy to move the ISS out of the way of one piece of debris coming towards you. When there's a whole cluster of debris coming towards you, you have to move it much further. The other thing is that these debris swarms will gradually disperse. Okay, so that means then they're less concentrated, but they're covering a much larger volume of space, and sooner or later something is going to hit and cause major damage or a fatality to an astronaut. It's inevitable, and the consequences are, they're frightening to think about what happens after that.
That's the thing. We're getting more and more, orbital companies coming online and wanting to send up space hotels and send up tourists, etc. The Exploration 4, the Inspiration 4, sorry, mission a few months ago. Classic example of what can be done now, and we want to encourage that. We want to encourage the peaceful use of space and good scientific use of space. We don't want more and more mega constellations. The whole OneWeb thing angers me so much, even before they were going to launch from Kazakhstan and support the Russians and give them loads of money. They've known about this. Don't tell me. They've been tweeting about this for months. They've gone very quiet of late, OneWeb, but this whole situation with the Black Sea and the Ukraine and Crimea, this isn't a new thing. This has been building up for months. So OneWeb really don't have an excuse to say, oh, it costs us too much now. It's a pretty, and ITAR regulations, etc. They could have stopped this a long time ago. This was a known issue that was growing and growing. But anyway, moving away from the politics, it is a major problem, and we will keep on top of this. We'll keep focusing on this. We'll keep talking about it, and hopefully more and more of the bigger players. And somebody said to me, interesting thing on social media via back channels, they were saying, it's a real shame that we've got people like myself, and I know there's lots of people in the chat thread, etc., who have got very similar views, and people like Carolyn Porco, but we don't have the really big guns. We don't have your Brian Coxes. We don't have the really big names coming out and screaming about this, in a David Attenborough kind of way, saying, look at what Attenborough did with ocean plastics, and that raised public awareness massively and forced the big companies, the McDonald's, etc., of this world to say, we've got to change our whole working ethos here. And it needs these big guns to come out, your Neil deGrasse Tysons, your Bill Nye's, your Brian Coxes, to really not just occasionally mention it, whatever. I know deGrasse Tyson does say a few things, but it really needs some strong action here. And yeah, Chris is saying there, OneWeb is at a horrible altitude. Yes, it is. Some of the work that I do with satellites for the defence sector, this is a big problem that the Ministry of Defence in the UK is looking at quite seriously, and it's a major problem. So yes, you're absolutely right there, Chris. There's not a lot we can do now. Just hope that nobody dies is the key thing. And this is, I'm sick of hearing supposed statisticians and scientists saying, it's not going to happen. Or space is big. Rubbish. It's going to happen. It's not if, it's when. Anyway, moving on. We'll finish the show with happy stuff that you can see. Oh no, we got the asteroid. Yes. Sorry, Terry. This one.
This is both good news and bad news. It's a milestone, in that they have discovered now the 10,000th medium-sized near-Earth asteroid. And the good news is that they are gradually ramping up the numbers, but as we'll see in a moment, they're still not even halfway yet to getting the total. So just to put the context on this, near-Earth asteroids or near-Earth objects are ones that come relatively close to the Earth. Near in NASA's terms can be up to a couple of million miles away, but basically they are ones that could conceivably in the future intersect Earth's orbit, which is something that we don't want to happen. The medium is defined in this context as between 460 feet and 3,300 feet in diameter. These are dangerous objects. If something in that size range hits us, we're going to really know about it. Just to give you sort of the context, the one that went over Chelyabinsk, exploded over Chelyabinsk, was about 17 meters or 56 foot in diameter, and that caused a fair bit of damage. Didn't kill anybody, quite a few injuries. That is many orders of magnitude smaller than what we're talking about here. So, as I say, it's both good news and bad news. The actual figure now that on the list of these medium-sized NEAs is 10,004. So that means we've discovered 10,000 of them, and of those 10,000, none are heading for Earth within the next century or so. A few near misses, but none are actually going to hit us as far as we know. The bad news is that they estimate, the total of near-Earth asteroids is 28,266, and the medium-sized ones that they have discovered so far is just about a third of that total, just over a third. That means there's still 2/3 to be discovered, about 40% so far, basically. So, of the ones that we haven't discovered, those are the ones that could potentially be heading for Earth. There are all sorts of angles to this, and I mean that literally. The ones that we can spot out beyond basically beyond the orbit of Mars and so on, looking away from the sun, relatively easy to find. The ones that are dangerous are ones that come from roughly the direction of the sun in the sky, where we can't observe them until they're almost on us. And then you don't have time to take any remedial or mitigating action. So there are 2 new projects underway which will help to discover the rest of these. Number one is the Vera C. Rubin Observatory, to be built in Chile, which is being built in Chile. It should be ready by 2023. It will detect a lot more of these. It will have a sort of a very effective way of detecting them in terms of imaging, very wide field imaging. And also NASA is planning another space telescope specifically to look for these objects, the Near-Earth Orbit Surveyor, which they hope to launch in 2026. So as I say, it's good news in that we're gradually discovering more and more of these, but it also makes us realize that there are an awful lot of them out there that we still haven't discovered. And until we have orbits for all of the ones that could potentially hit us, then we have no guarantee that we're not going to be hit by something pretty sizable, a city killer, possibly even a county killer or a country killer in terms of the amount of damage that they might do. So we're getting there, but we have a long way to go still before we're safe. And that then does not even address the issue of an impact from a comet, which is a whole new ball game, and maybe we'll discuss that some other time. So as I say, good news and bad news. We're gradually discovering more and more of them, but there's an awful lot there still that we haven't discovered yet. Just hopefully none of them are heading our way in the near future.
Yeah, cometary impacts. I mean, that movie Don't Look Up obviously parodied it quite successfully, but and there were a lot of technical mistakes in it, but it's there. And comets are a bigger problem, as you've said. The other big thing that we touched on before is the Vera Rubin telescope. As you said, Terry, it's a very wide field survey telescope. You look at what's happening in Arizona with, the Catalina Sky Survey and all of the other wide field survey telescopes. So amazing. But if you put loads and loads of satellites in orbit, then your data reduction pipelines, a lot of, you're not talking about astronomers looking at little dots moving on the screen. You've got automated data reduction pipelines which are looking for moving objects, and if you've got an absolute bucket ton of Starlinks and everything else crossing your screen and blanking out your cameras, because the magnitude, even with the sun shield on Starlink, you're looking at magnitude 7 or 8, which if you've got telescopes that hit magnitude 24 quite easily, and they've got anti-blooming CCD or non-anti-blooming CCDs on them, and that's basically, blooming is when you get that kind of the pixels, as it were, saturating the wells in the individual pockets of the CCD and then spilling out into the other bits and creating these great horrible spikes, which you sometimes see on star images. How do you get around that if you've got a satellite at magnitude 7 going straight across your field of view and just creating a great big bar of gunk? It's an interesting problem. But yeah, it's good that we are detecting them. A low Earth orbit detector will be great, hopefully high enough to avoid all of the debris mess as well. Who knows? Even if we were to detect something coming our way, especially a comet, we've got months. So anyway, let's finish on a high. Let's finish on something. What have we got to look forward to, Terry, in the sky?
Yeah, unfortunately, it's a relatively quiet time in terms of the planets, and spectacular things to look at will be a bit more there'll be a bit more coming up in the near future, but there are nevertheless a couple of things. I'll keep the best one to the last. Earthshine is a fascinating phenomenon, sometimes called the old moon in the new moon's arms, and for the next 5 or 6 days or so is an excellent time to see it. And you see it just before or just after new moon. So new moon's round about now, and over the next couple of days, when you look at the crescent moon, when the sky gets dark, you'll see that you can see the whole of the moon's disk, not just the illuminated crescent, and that is called the Earthshine. And what you're seeing is light reflected from planet Earth onto the moon, lighting up the moon's surface, and then reflected back to Earth again so that we can see it. So if you were standing on the moon at the time that we're looking at the Earthshine, you would be, as an astronaut standing on the moon, looking at what we would call a gibbous Earth. The Earth would be not quite fully illuminated, but much more than half illuminated. And of course, the Earth being a lot bigger and brighter than the moon, it would look very big and bright in the sky for an astronaut standing on the moon. So what is happening then is that light is reflected back to us and we can see it. And it's fascinating. And if you look at it in a telescope or a good pair of binoculars, you can actually see detail on the surface of the moon in the area that's not illuminated directly by the sun. It's very beautiful. You get some fantastic photographs showing both the bright crescent and the glowing part lit by the earth shine. So that's one thing. The other thing is a much more difficult phenomenon to see. It's called the zodiacal light, and you need very, very dark, clear skies to see it. So before the moon gets too bright, say up until about the 4th of March, if you're lucky enough to either live in or be relatively close to an area where there's practically zero light pollution, if you go out and look towards the west, after the last vestige of twilight has disappeared, you can see a faint cone of light stretching up at an angle from the horizon along the line of the ecliptic. In other words, if the crescent moon is there, it'll be approximately on the line from where the moon is at the moment as you look at it, and down to where the sun would be below the horizon. And that's caused by myriad very, very fine dust particles in the plane of our solar system being illuminated by the sunlight, much too small to be seen individually, almost like sort of a mist or a fog. Some interesting news just recently as to what that might be, where it might come from. There's some thought that is actually caused by meteorite impacts on Mars, but don't have time to go into that. But you do need a very, very dark sky to see it. And finally, our good friends up in the International Space Station, they are continuing morning passes until the 10th of March. So we see it just before the sun starts to brighten the sky too much in the morning. And then there'll be a series of evening passes starting on the 18th of March. And why is that a good news story? It's because there are astronauts up there from both Russia and America, 4 from the USA, 2 from Russia, and a German. And I know for a fact that they are getting on with science. They are ignoring all the terrible problems that we have here on the ground. They're putting that aside and they're getting on with science. And hopefully what's happening on the ground is not going to affect them whenever they come down. They're due to land, I think, in the end of March in Kazakhstan, which is not Russia, but it's under, that area is under Russian control. So we wish them all the best up there. Get on with doing the sensible science up there, folks, and hopefully the ones down here on Earth can learn that it is possible for people to get together, even they come from totally different political backgrounds. So on that note, I'll finish.
Absolutely. I mean, I couldn't echo that more, Terry. It's a wonderful sentiment and a wonderful statement. And yes, we do want to see science kind of succeed. Interesting in the chat as well. Good reminder from Chris and people in the chat talking about the JWST launch tonight. ULA, Lockheed Martin and their partners, United Launch Alliance on an Atlas V. That's going to be pretty good. Another weather satellite. We need. This is the thing. We rely so much on space for so many things, for our climate monitoring. We're undergoing a climate crisis as well. There's so many reasons why space and science is so important, and we can't ruin that. So, if anyone of any influence is listening, or, hopefully we're not the only people talking about this, can kind of rattle some heads and say, look, as Edgar Mitchell once said on Apollo 14, he'd like to drag every single politician up to the surface of the moon, show them the Earth and say, see that, you, and then he used a few expletives. That's all we've got. And on that note, I'll end as well. Thank you very much again. Massive thanks to the Space Store and our backroom team, who are remarkable, and they stick with us and they are so supportive. Really great from a technical standpoint, etc. And they managed to get through all of the shows and help us so much. So huge thank you to the guys in the background who do so much for us. We'll see you in 2 weeks, hopefully, unless the world's been annihilated. And I'll hand you back over to our wonderful Space Store people.
Just finally, I see Chris's comment there. Couldn't agree more. You can't see borders from space.
Yep, absolutely.
And that's it. Bye, folks.
Thank you, Nick. Thank you, Terry. That was a really good show. Big thank you to Chris, Ground-Based Space, and Mary in the chat. It's been a really good, lively chat today. We hope you all enjoyed the show. Just a few notes, just to make sure that you subscribe to the channel, and if you're interested in following us on Facebook, Instagram, Twitter, we've got a bunch of Space Store offers, and obviously we've got all the space news coming out like this. We put a few short clips out on YouTube, just summarizing what Nick and Terry have been talking about. So it's really good to follow us there. If you're in the Didcot area,
great t-shirts.
And great t-shirts. That's it as well. If you're in the Didcot area, you can come down and give us a visit. We're open every day from 10 a.m. till 4 p.m. And then the last one is a big, big thank you to our space partners, Ocean Mind and Oxford Space Systems. They're just helping us out here, making sure we can keep growing the space community. So yeah, you can find out more about them, about Space Store, and about this show through our website. And you can also check out all the awesome other stuff we do. So yeah, thank you for that one, guys. Take care. And yeah, everyone stay safe.
Stay safe. See you in 2 weeks.
As an aging hippie would say, peace and love.
Peace and love. Peace and love.
Bye.
Bye.
Cheers. Bye.